Good morning, junior scientists and not so junior scientists. Welcome to Virtual MOSI. My name is Charlie. I'm one of the instructors and amateur astronomers here at the Museum of Science and Industry. Today we have a great topic for you. It's a big one though. Global warming. Now it's a very important topic for us to talk about. In fact, bigger than I can ever get in our little segment here. But before we actually get to the meat of our subject, I have a question for you. We're going to begin with a MOSI brain teaser. Now I'm going to give you the question at the beginning, and I'm going to give you all the show long to answer the question. At the end of the show, I'll tell you what the answer is, but see if you can get the answer in before then in the chat box. In the chat box also you can ask us questions and make your comments. Let us know what you're enjoying. So our teaser today is, which planet has the greatest temperature differences in a single day? So one of those planets is really a crazy bunch of differences between the night and daytime temperatures. So think about that, and meanwhile, let's get busy with our topic of global warming. Now, before we talk about global warming, we need to make sure we understand the difference between weather and climate. Now, weather is what the sky is doing right this very minute. This morning when I was driving in, it was a beautiful day. No clouds, no rain, beautiful sunshine. It was humid because we've had lots of rain recently, but it was still a pretty day. Climate is a different idea. Climate is when you take those weather patterns and you think about them for a long period of time in a certain place. So basically, climate is like history, where you're trying to look at what the weather has been consistently over the history of a particular place. And climate change or global warming is really what we're talking about today. Not what the weather's like today, but what the weather's been like historically. Now, an article just came out this week in our local newspaper, the Tampa Bay Times. The article's called Seasonal Imbalance, and it talks about a study that's been done over basically my lifetime. The study compared two 30-year periods. One beginning when I was born in 1960 and going through 1989, and another beginning in 1990 and going through last year, 2019. So basically the study compared these two 30-year periods to see what the temperatures are doing. Now what they found in this was that the summer season has increased by an average of 7 days. Now how they found this is, they're not looking at the calendar to say what summer is, they're looking at all those highest temperatures during the year strung together. And so they found worldwide that the world is experiencing 7 more days of summer temperatures and 15 fewer days of winter temperatures. So basically we're getting more hot days and fewer cold days. They also found that these changes are greater for people who live in certain places. Like for instance, if you live in the southern United States, the changes are bigger. We here in Tampa are in the southern United States. If you live in a city like we do in Tampa, the changes are different. If you live near the oceans like we do in Tampa, the changes are different. So you can expect us to have bigger numbers than these worldwide changes. I don't know what the data shows for Tampa, but I do know what it shows for Miami. They found that Miami winter decreased by 49 days. We had almost 2 months fewer cold temperatures between these two periods of time. But we had 37 more days of summer temperature every year. So we increased summer by basically a little over a month and decreased winter by almost 2 months. So if you feel like you're not really experiencing any winter anymore, there's a reason for that. So the weather's changing, and those changes have a lot of effects all worldwide. Now, we don't have time to go over all the differences that can make, but here's one small example. Now this is from NASA's Earth Observatory. There was an article a few days ago that talked about how Antarctica had its hottest days on record. In fact, February 6th, NASA recorded the highest temperature that's ever been recorded in Antarctica at 64.9 degrees Fahrenheit. Now, 65 degrees sounds like a beautiful day in Tampa. But Antarctica, that's 20 degrees higher than it's ever supposed to get. So that's pretty hot. In fact, strung all together, Antarctica is experiencing its hottest summer ever. Summer? Wait a second. Oh, you need to remember, by the way, the seasons in the southern hemisphere are opposite from the ones that we're experiencing up here in the northern hemisphere. So while we have been experiencing winter, Antarctica's been having its summer. More about that next week when we talk about the seasonal changes. So in 1 week, Antarctica lost 20% of the ice and snow that accumulates over an entire year. And all that melted snow and ice results in rising sea levels, which is a big worry for us here in Tampa. Now, there are reasons for everything. We have been studying this temperature change, and as we study the temperatures changing on our planet, we also notice an increase in certain gases in our atmosphere. Now, our atmosphere is made up of several major components, mostly nitrogen, about 78%. It's about 21% oxygen, and that leaves 1% for everything else. And that's greenhouse gases, water vapor, you name it, all that other stuff. But that 1% makes a big difference. Greenhouse gases are really the thing that we are seeing causing the temperature increase. And there's tons of research on this. So what are greenhouse gases? Simply put, they are gases that absorb the sun's heat energy. Now, usually, the sun, of course, beats down on the earth during the day and it heats up our planet. But then at night, all that heat is supposed to radiate out into space and escape from our planet, so our nights are cooler. But those greenhouse gases are trapping the heat and not letting it escape. And that's what's making our temperatures rise. So what are the greenhouse gases? Well, there are 4 major ones and a whole bunch of not so major ones. Carbon dioxide is the one that is most influential. Now, you've probably heard of carbon dioxide because all animals breathe out carbon dioxide. We do too. So every breath you exhale, you're giving out carbon dioxide. It also comes from things like forest fires, volcanoes. Burning fossil fuels, though, is man's contribution to that. That's where we burn fuel in our cars or campfires or coal in our factories or whatever you want to talk about. So carbon dioxide is a big one. Water vapor, believe it or not, is a greenhouse gas. Now, most water vapor comes from evaporating over our oceans, and there isn't a thing, of course, that humans can do about that. But a lot of it also comes, also from trees, by the way, but there are also human activities that also contribute to the water vapor that comes into our atmosphere. Methane, kind of natural gas, actually, comes from, well, animals farting. Hey, everybody does it, come on. And a lot of what that is methane. It also comes from things like landfills where our garbage is decaying. Also from industries give out methane as well. Nitrous oxide, some people call it laughing gas. Not much to laugh about. It comes from forest fires, but for humans, it also comes from industry and, again, burning those fossil fuels. Now, you may be saying, wait a second, how do you know that these greenhouse gases really do affect temperatures? Well, you can actually prove it for yourself. I have here an experiment that you can put together at home. It has pretty basic things that most people are going to have lying around their house. What you're going to need: 2 clear, empty 2-liter bottles, or for that matter, any identical 2 bottles or jars will do. You're going to fill them up equally, halfway with water. You'll see that I colored mine blue. There's no need to color your water blue. It just makes it look prettier. You'll need 2 kitchen thermometers. Now, I just happen to have 2 matching thermometers from my kitchen that actually work perfectly for that. You're going to need some Alka-Seltzer tablets, 1 pack of 2 tablets. So why Alka-Seltzer? Well, you're going to put Alka-Seltzer in one of the bottles, and that Alka-Seltzer, as it dissolves, gives off carbon dioxide gas. We use stoppers to hold that gas inside the bottles so it doesn't escape. A stopper can be a lot of different stuff. Clay, foil. I'm using these little pom-poms. I happen to have some big ones. But anything that kind of closes the bottle and keeps the gases inside will work. By the way, when you put the Alka-Seltzer in the bottle, you don't want to screw a cap on tight or something that truly seals the bottle, because those gases are going to expand a little bit and you don't want to have the top pop off. And then you need a source of heat. Come over here and I'll show you what you're doing. This is actually an experiment that I set up just this morning. Now our source of heat is a heat lamp, but if you use the sunshine, that's perfectly fine. If you don't have a heat lamp, just look for a sunny day to do this experiment. You're going to need to have it out in the heat for at least an hour before you really see differences in temperatures. This experiment has been going since 8 o'clock. So in the one with the purple palm, I just have regular old air from the room. And in the one with the green palm, I have where I put in my Alka-Seltzer tablets. So when you put in the tablets, by the way, you're going to have to crack them in half to fit them through the neck of a 2-liter bottle. As soon as you put the tablets inside, make sure you seal the bottle's top with the pom-pom so the gas won't escape. So my data actually isn't really crazy impressive. Both of them started out at 76 degrees. And by 8:45, the one with the greenhouse gases in it, the Alka-Seltzer tablet, was at 83 degrees, whereas the one for with no change at all, my control, is 81 degrees. Now that's 2 degrees difference. Right now, it looks like it's basically holding right there at about 83 and 81 degrees. Now that 2 degrees difference doesn't sound like a lot of difference, but when you're talking about climate over great periods of time, 2 degrees makes all the difference in the world. So this is really, you don't expect to see huge differences, but there is obviously a real difference. And this experiment does show the only thing different is the carbon dioxide in that bottle has absorbed more heat than the regular air in this bottle. So greenhouse gases, then, it seems, are warming our planet up. So what does that mean in the bigger picture of things? Well, as we've already talked about, some of those greenhouse gases come from natural sources. You're not going to stop the oceans from evaporating. Okay, there's not much you can do about forest fires other than put them out sometimes. Volcanoes will do what volcanoes do. All we can control as humans is what we do as humans. And so we have a chance to change our world for the better. We don't have to accept all these global changes. Now, first of all, adults can do all kinds of things to change how our environment works. If you're an adult, you can vote for people that are going to make sure industries are regulated so they don't have bad emissions. You can choose to buy an electric car. You can choose to take the bus to work every day. You can choose to have a solar energy installation on your home. There are lots of things adults can do. But what can a kid do? That's what we want to talk about here. And kids, you can do a lot. Check this out. A kid can conserve energy. When you're not in a room, turn the lights off. That empty room does not need to have lights on in it. It doesn't need to have the ceiling fan running. When you're at home, adjust your temperature so that you're comfortable but not too comfortable. For instance, when it's hot outside, nudge that temperature up just a smidge. You'll still be cool, and yet you'll save plenty of energy. And every bit of energy you save is some fossil fuels that aren't being burned to make that energy. You're helping. Shorter showers, okay? 5-minute shower, boom, boom. Saves lots of energy and water as well. You can plant trees and other plants. Every tree you plant is going to be sucking up a lot of that carbon dioxide and giving us oxygen that we need to breathe, so green is a good way to go. You can find ways to limit driving. If you need to just go to somewhere that's really close, instead of having your mom or dad drive you in the family car, try walking, riding your bike. You'll save energy there as well. Try and take the bus. Of course, every bus that's filled with people takes 20 some odd cars off the road, and that can make a big difference. And of course, since we are in the middle of a pandemic, participate by internet. We've gotten everybody involved in Zoom meetings and such like that, And when you're zooming, well, you're not driving. And so that's another way you can help. And then finally, kids, you can encourage other people to help keep our planet safe from greenhouse gases. Talk with your parents. Talk with other people about why greenhouse gases are important and what we can do to help limit global warming. Are you just a kid? Do you think you can't make a difference? See this kid? Greta Thunberg from Sweden. Greta is a teenager, and she has traveled around the world with a message of combating global change. If you Google climate change on your computer, you'll probably come up with a picture of her too. She has talked with the United Nations, with just about every leader of every country throughout the world, and she is working hard to make a difference because, after all, the future belongs to kids like her and like you. So you too can make a difference. So you see, folks, there's a lot that can be done. There's a lot of work to do. Like I said, this topic is bigger and more complicated than we'll ever get in a virtual MOSI thing. So I want you to keep discovering this with your parents. Talk about it, explore it on the internet, find out more information. Speaking of information, have you come up with an answer to my question yet? Urmila, does anybody have an answer for us?
We have one guess, and then we also have a few questions for you.
Oh, okay.
So we have one question. One person can't believe that we lost that much ice. Do you think a couple of degrees would have added to that?
Well, remember when I said that they had their highest temperature ever there, it was 20 degrees higher than their normal temperature. So it wasn't a couple of degrees difference on that day. And again, the ice melt that you get in 1 week is not going to be the ice melt you have all summer long. Okay? So different times going to have different temperature effects. But yes, every degree you save makes a difference. Did you have any other questions I should answer?
And for the experiment, instead of using a lamp, would putting the experiment outside in Florida during the summer be enough?
Absolutely, if the sun is shining. Okay, it's not enough to just have it outside in summer. You want to have sunshine because that sun energy is what's going to drive your experiment. So yeah, absolutely. No heat lamp, wait for a sunny day. You try it again. Okay. So we're going to repeat our question here. Which planet has the greatest temperature differences in one single day? Your answer is planet Mercury, the closest planet to the sun. Now, it's weird to talk about weather on planet Mercury because, after all, it has no atmosphere to speak of. But planet Mercury does have very huge temperature differences. During daylight, the side of Mercury that faces the sun, it roasts at over 800 degrees Fahrenheit. Meanwhile, the opposite side of the planet, that's in the cool of night, is an extremely chilly negative 300 degrees Fahrenheit. That is 1,100 degrees difference from one side of the planet to the other, from day to night. That's pretty crazy. Another crazy fact, by the way, about Mercury is every day on Mercury, at least the day-night cycle on Mercury, is 187 Earth days long. So that's a long day. A long, hot, or cold day, depending on which side you happen to be on. So there you go. Now, this question allows me to put in a plug for our next virtual MOSI, which is coming up this Thursday, when I'll be talking about the seasons in our solar system. So I hope you'll tune in at 9 o'clock next Thursday to learn how the seasons are different on all the different planets in our solar system. Going to be fun. Now, there's our topic on global warming today. It's a big subject. A lot of people get excited talking about it. A lot of people get worried about talking about it. But folks, we need to talk about it and think about it. You kids are the key. You all are the brain power. You all are the future. And I hope that y'all all enjoy our show and that you keep discovering.